Hello and welcome to Aston University's coverage of COP26 with Aston Originals. Today we are talking about plastics. It's been discussed in Glasgow today. So we are joined by Dr. Timothy Whitehead from Aston University and Dr. Mark Evans along the M42 at Loughborough University. Hello to you both. Let's start with a little bit of an introduction though, starting with you, Timothy.
Hi, I'm Tim Whitehead. I'm a lecturer in product design at Aston. Yeah.
And Mark.
Hi, I'm Mark. I'm a reader in industrial design at Loughborough University, and I teach industrial design and do research into tools and resources to help industrial designers make or design better products.
Perfect. Well, Tim, let's start with you. What's been going on at Aston University recently?
Yes, it's been we've been obviously doing a lot of kind of research in the area of plastic waste and looking at how we can use plastic waste. And I kind of thought this is quite an interesting time to talk about one of our projects called Circular Plastic, where we're working with Kenya and Nigeria and Rwanda to look at how we can recycle plastic waste, such as plastic bottles, but actually not just recycle it, but add value to that. By creating 3D printing filaments, so looking at new technologies, frontier technologies, to really add value to that plastic waste. So just to give you an example, like, maybe a ton of kind of just recycled PET filament, plastic waste, costs maybe about £50 for a ton. But then if we add some value to that, if we create a resource, in this case, 3D printing filament, we can significantly add the value. It's about £20 a kilogram for 3D printing filament. And then we can 3D print new products that use that resource to add significantly more value. So this is what we're kind of looking at. We're looking at how can we really add value to plastic waste and stop it going into the oceans. So think about 72 million tons of plastic waste are created every year. About 8 million tons of that go into the oceans. So we kind of want to try and stop that and actually do something really interesting and different with it.
I think your colleagues from Ebri and Supergen were on Aston Originals last week just talking about the technology being there, but nobody willing or seemingly being willing to take the risks that's attached to transferring over to something that you would consider to definitely be more green. But money does talk, Tim, and just along the bottom of the screen now, people can see, what sort of costs are involved and the value added, and it is significant, isn't it?
Yeah, it's really significant, and I think this is what I'm kind of interested in. So we think of plastic as quite low value, kind of a plastic yogurt pot, a plastic bottle, or something. But actually, if we claim that plastic back, turn it into a new product that has significant value, and hopefully we'll show some examples in a minute of what we've been able to do with some of that plastic waste.
Perfect. Mark, what was it like working on the project?
It was a great project. I mean, industrial designers are creative by nature, and to be given opportunities to design and actually prototype new product opportunities using what is essentially a waste material and add value and, I guess, improve life opportunities for groups of individuals that wouldn't normally get these opportunities is it was a great project to work on, exciting and very fulfilling.
I guess same for you, Tim, as well.
Yeah, it was great. So we worked with 3 countries. So we worked in Rwanda, in Nigeria, and Kenya. And what we're actually doing is we were creating these hubs, these kind of recycling plastic hubs in each of these places. And that was just really, really interesting to see how we could work with the local people, where we could collect that plastic waste from, the value that we could add. But then ultimately, what products could we create? What products are needed in these situations? And just as opposed to importing stuff, I think this is another thing that we're really interested in, is about supply chains and about how we're constantly importing our products from overseas, and how can we have local manufacturing using local waste resource to create interesting and novel and essential products for these people. So yeah, it was a great learning experience and working across different cultures, and yeah, it was really, really interesting.
Now, if the technology will allow me, would you like to show some of those pictures that we had ready? If we put this one in, just to explain what this is, Tim.
I'm gonna hand over to Mark to talk through these. But yeah. Mm-hmm.
Okay, I mean, I was working with the design team, so there was myself and two other industrial designers, and I think what's particularly appealing about this project is that there is no requirement for tooling. So we think of most products, whether it's a washing up bowl or a hairdryer, you need to create tooling, large lumps of steel, where you inject molten plastic and out pop the parts. With 3D printing, which is what we were using for this project, because the filament for 3D printing was from the recycled bottles, there is no tooling. The 3D printing is a layer-based build process, so you don't need very expensive tooling, 10, 20, 30,000 pound tools to create one object. It creates individual objects through a process of layers. So, for example, the fruit picker, we could identify types of fruits that were being picked. In this case, it was in Rwanda, but soft fruits that get easily damaged. And we could create a customized product for a region. So that the tangs on this device, the ripples, were actually designed to optimize the picking of certain fruits, in this case, avocado. And even the bamboo that we used, that we gathered, if there was a particular crop of a certain diameter, we could optimize the print of the product for that available bamboo. So everything is kind of customized to a local need, which you don't typically get with high volume manufacturing techniques. So the fruit picker was very successful, enabled fruits to be picked without them getting damaged, thereby increasing capacity and the profits from the production.
We were also having a little bit of a game of what other things these pictures look like. So I have no idea where to start with this one.
Okay, well, this is a non-electric milk cooler. So again, in all of these African countries, Rwanda, Nigeria, Kenya, refrigeration is a problem. So this uses the intricacy that's possible with 3D printing, because again, I'll stress there's no tooling cost. It just makes the thing in a series of layers. And by having this kind of this matrix structure with some wadding, there's some wadding inserted inside it. The wadding's wetted and evaporates using this kind of open structure, this matrix structure, which actively cools. So it kind of creates an active cooling, but there's no power. So it means that products such as milk can be effectively refrigerated with nothing more than evaporated water, and using the intricacy of this kind of matrix, this mesh, to promote the evaporation of the water.
And so, what sort of temperature could we potentially be getting milk down to? I imagine in these countries which are fairly hot.
Well, we can't give a temperature because it's going to vary from region to region, but it actively cools it, and it actively promotes the longevity of the milk. So it's, rather than being ambient temperature, which is going to be relatively high, and this is a relatively concept in terms of temperature, it will always be significantly cooler than the ambient temperature. So it will promote longevity and increase the life of these products.
And what have we got on the screen now?
Okay, some regions of Nigeria, that they actually scoop up sand from riverbeds, particularly in Lagos. And it's a way of getting sand for building materials, and it's a kind of a cottage industry. But the way that the sand is actually scooped up from the seabed is actually quite primitive, using little more than buckets. So to optimize that process and increase efficiency, we could create this customized scoop that is created specifically for the prevailing buckets that are used in a region, and it's just retrofitted, bolted onto a bucket to enable the workers to more effectively scoop and get a high yield of the sand every time because they do dive down. It's a breath hold dive. They dive down, scoop up, so they can actually get more material for every dive that they do.
Could they do a really, really long snorkel? Would that help them in their venture?
Sadly, I do actually have a bit of a background as a diver, and long snorkels don't work.
They don't work.
It's not physiologically possible because you go deep and it compresses your lungs. But this does enable a breath hold dive to get a larger scoop. Every scoop is larger using this device.
Perfect. Next one we'll move on to. I thought it was a net in the background, but it is just a reflection of the water, and it is a boat. But just to explain what we're seeing here.
Yeah, so it's actually the hull of another boat you can see there, but we call this the adaptable boat baler. So it's kind of an upside down U structure that we designed and created, and the Coca-Cola bottle that you can see attached to it could be any bottle. Ironically, we use filament to make these devices, created from ground up bottles, and we've actually used a bottle as part of the structure of the product here. So the empty bottle has the bottom cut off, it sits on the water, and then as the boat rocks or there's wave action, it creates a suction. It creates suction which actually empties water from the boat. The boats used by these people, this is actually in Kenya, are notoriously leaky. And they tend to start filling with water. So there's a small hose that goes into the bottom of the boat. It then links to this bottle, and the rocking of the boat creates a natural suction to bale, to empty water from the boat. So hopefully there are going to be less instances of boats sinking due to filling with water.
Well, I wish I'd known some of this technology was available. My washing machine actually broke last week, and I had a long pipe going out the door and down. Because I was like, don't worry, I'll do a suction thing, and ended up obviously with a mouthful of dirty, rancid water. So I should have spoken to you last week.
You could have used our adaptable boat baler.
I feel like an idiot. Right, okay, what have we got here? I said sunken pool table, but that's not the case.
It's not a sunken pool table. Hopefully you can see the fish. So this is to promote aquaculture, and it's a modular fish farm system. So modularity is a great technique because we can expand and we can scale things up. So the blue things it's based on basically two components, a corner component and a linking linear component. So aquacultures use fish such as tilapia, freshwater fish, are produced in these African countries or reared in these African countries. So this enables the linking together of bamboo cane to create a structure. What you can almost see in the image is a net. So suspended into the water is a net that keeps the fish captive. That's, I guess, the smallest level of fish net system we've got there. But as you can see, you can link it up. It's almost a Lego set. So the more fish you have, you increase the size of the net, add more bamboo, and you can have a larger yield of fish. And they float because there's a cavity in the middle of the blue bit, so it just floats on the water.
Incredible. Let's have a look at this. This is one final one from you, I think, Mark, before we move back to Tim.
Yeah. So this is we'll call it a customizable machete peeler. So things. Peeling of fruits, cassava, it does generate a lot of waste if you use just a standard machete. The designers did some kind of research, and there's huge piles of particular cassava waste. So what this does is we look at the typical machetes that are used. We create this device that supports the blade, but also orientates it at an optimized angle for that fruit. So it optimizes the angle for actually peeling whatever fruit it is, in this case cassava. So it reduces waste, it makes it a safer operation and a more effective operation. So that's the customized machete peeler.
Love it. Love the names.
We try our best.
Tim, we're going to move on to some of the other people that you've been sort of working with through this process. Would you like to just introduce Solomon and just before we go into that video, just to explain how you've been working with him over time?
Yeah, no, definitely. So we've worked with Solomon, who works for Tech for Trade, and an arm of that is called Digital Blacksmith. And what they've been doing, they're based in Kenya, and they started to produce the technology to enable this all to happen. So what we're working with is a locally designed extruder that takes the plastic bottles, we chip them, we shred them, and we put them through an extruder so they get nice and hot, and they're extruded as 3D printing filament, which is the main part of what they've been working on. And then we can put that in our printers to print all the things that you've seen. And I think hopefully those case studies kind of were really nice because they showed the complexity. We can get a lot of complexity with the 3D printing, and all of these are kind of bespoke one-off parts that, products that you wouldn't be able to traditionally do with manufacturing tooling, or the cost would just be expensive. But yeah, I think we've got a little video from Solomon.
Perfect. Let's take a look at that.
I graduated from the University of Jomo Kenyatta University here in Kenya. And so after my graduation, my main area of research was in 3D printing. So our ideas or our focuses matched. And so I have a deep interest on cleaning the environment. So when we merged the two ideas, we figured out that the next thing that we could do is now try and figure out how we could convert 3D printing into a waste collection and a waste recycling manner. And so we researched on different kind of plastics. Finally, we rested on PET, which was very good for printing. So with that, when we got PET, we've now been extruding it to figure out what are the extrude temperatures that we need to set, how do we need to adapt our machine to produce the quality and standard of filament that will be usable to every other printer. The filament, we made microscopes, and the microscopes that we've made, we've actually piloted with 12 schools around Nairobi. And so these schools have actually had an interaction with the different kind of with the new kind of microscope. This microscope is a digital microscope, and it can actually be able to give a digital image of the enlarged image, so to speak. Besides that, we've partnered up with our local team, the Kenya Institute of Curriculum Development, which is the local curriculum developers in our country. And at this time, our country is in the process of developing the competency-based curriculum, which means that the learners have to be experiential. They have to touch and feel whatever they are using. And so with the 3D printer, it's very easy to produce tangible objects, and these are the kind of objects that now we are moving forward to make with the curriculum of with the Kenya Institute of Curriculum Development.
Some interesting stuff in there, Tim. What's Solomon like to work with?
Oh, he's excellent. No, he's really hardworking. He's always communicating, and he's great. I think what's really nice is that they're working within the Kenyan education system, and it's trying to bring. I think this is quite interesting. It's trying to bring the technology, this frontier, this new technology, STEM education, into an area of plastic recycling and managing and looking after the environment. So I think that's just a really nice combination that he brings.
And Mark, what about from your point of view too?
Yeah, I think the key is the design sort of phase of the project just demonstrates that designers are very much agents of change, and they do have the capacity to translate often intangible ideas into tangible products. And I think this showed that if you couple new technologies, i.e. the transformative process of the filament with design capability, you can get tangible, real life-changing outcomes. And working with the team, it certainly was a valuable case study in that process.
Before we look at some of the products that have been made on that side of things, I think that the question on loads of people's lips, I imagine, is how have you managed to swing such a brilliant project in Africa? Because you're going there next week, aren't you, Tim? You've managed to bag yourself a holiday. I can't believe it. They could have come here, I'm sure, but you've managed to swing an African safari. It's
not quite going to be a safari. Yeah, but no, I'm flying out on Monday over to Kenya to see the team. Because of 90% of this has been happening through COVID, our project. So obviously, I did know the project partners beforehand and had been out previously. But yes, so we've had to do a lot of remote work. They've been excellent, and yes, I'm really looking forward to going out, seeing what they've been up to. Actually in person, meeting the team, and almost kind of thanking them for what they've been up to, and then looking at the next steps and where we go from here.
And Mark, have you found it working through COVID? Because, for a lot of people, many people, it's turned a lot of things upside down, but we sort of get used to that way of working. And I know it's overused, but the new normal and that sort of thing. But how has it been over that last period of time?
Yeah, I think designers are used to working globally anyway. and we were fortunate that the Rwandan collaborator could organise focus group type activities, so gathering potential users and stakeholders together and having productive, we call it co-designing, where we actually engage with potential users of products and gather insights. So that was actually still extremely effective. We had meetings online, and the design team sat in on those meetings, albeit they were in Rwanda and we were in the East Midlands. So it would have been great. The plan was to have gone out there, but at the specific time when we were doing that co-design activity, we weren't going anywhere for obvious reasons. But designers they're quite, they have a high degree of tenacity in terms of finding insights using secondary sources as well. So the combination of just Google and those co-design workshops worked extremely well. So yes, we were impacted, but I think the range and variety and creativity of the output showed that we weren't unduly impacted, which was great, because we could have been, and fortunately we weren't.
Excellent. Let's have a look at this. Now, it popped up on the screen earlier, so may have slightly ruined the surprise for everybody, but just explain what this is.
So this is a microscope. So this is a 3D printed microscope, and it works on Raspberry Pi, kind of portable computing technology, and it plugs into a mobile phone or equivalent laptop screen-based thing. And this is what they've been printing out in Kenya and working with local schools. So we're using plastic bottles as the main material. We're using 3D printing, and you can see the complexity of the geometry that we're able to achieve through 3D printing. And it enables a school to have a microscope which would normally cost, kind of thousands of pounds, for less than £100 or $100, for the whole kit and kind of resources. So I think they've got a number of schools. I think about 12 or so schools in and around Nairobi that have started using these and started building them. And that's the thing; they can build more. We can just build more and more as we need them. Print out more. They can fix them. They can repair them. They can learn about STEM education and about recycling all at the same time. So yeah,
brilliant news for schools. Less brilliant news for microscope manufacturers, I'm sure. Let's have a look at this final one. Let's pop it on the screen now. Just finally.
Okay, yeah. So finally, so kind of going forward, where do we hope this will go? So we've created 3 hubs. We've got one in Nairobi, one in Kenya, and Nigeria. And what we're looking at is taking this. We realise that it's great in the cities, but what we want to get out is into rural communities. So we've got these. This is kind of hopefully the next phase. Getting these kind of freight containers and making mobile manufacturing labs, kind of maker spaces that will go out into local communities. And again, we basically put plastic waste in one end. We produce filament, but also other things. So like we might not be 3D printing filament. It might be plastic sheets, which they could cut up. And it will be looking at using some more multi-material or local material resources. It's all about this kind of local manufacturing and making products to suit a local need. And that's kind of what we're trying to do with those little manufacturing hubs and take them out of the cities.
I think we might be able to sort of see one in action here. So that's sort of what it would look like. Because they're big structures as well, aren't they? Shipping containers. Lots of folks do at the moment. Right, okay. Let's round that off for the time being. A really, really incredible project, and thank you so much to the both of you for sharing insight into that. And it's really nice to be able to see them being used as well, just for that context. But let's end on a COP26 note, if you don't mind. Maybe along the lines of hopes and predictions, starting with you, Tim.
I think, my hope is that we can. So I think there's just so much plastic waste that's going in the oceans and it just put into landfill and all that. So I think my hope is, is that we can really try and sort that problem. That actually we can see plastic waste as a valuable resource that we don't want to just throw away and discard. But through design, through innovative technology, we can actually use it. Some of my students were even talking about this, about can we mine plastic from landfill, or can we mine it from I don't know, festival, one end of a festival, and everybody abandons their tents. Can we use that resource? You know, so it's trying to get that mindset. So that's what I hope, is that we can just see it for what it is a really valuable resource, and just not discard it. And yeah, hopefully the policies and things will come along to support that.
Mark?
And I think from a design perspective, you know, designers can be tarnished with being responsible for a lot of the plastic waste that we've generated. You only have to go to your local tip to see the amount of stuff that people are discarding, but they're also part of the problem now. And I'll stress again, you know, we've seen the creative potential that designers can contribute to moving towards carbon zero. And yeah, hopefully we'll move into a second phase of the project and actually get these centres up and running, and you know, scaling things up to make real change.
Perfect. Well, thank you so much for joining us. Obviously, head over to aston.ac.uk. There is a specialist COP26 page there if you want to go and check that out. Otherwise, we'll say goodbye to Dr. Timothy Whitehead.
Goodbye. Thank you. Thank you very much.
Dr. Mark Evans.
Okay, thank you very much. That's great.
And it's a goodbye from me. Goodbye.